Hello, viewers. Welcome to the lecture series of SSC Quantitative Aptitude. And this is your tutor Keshwa Agarwal. And this will be the lecture number 8 on average. So, in this lecture, we are going to solve problems based on average. And the problems will be mainly previous year questions. So, let us start with the first question. The average of 5 terms is 40. If the first 4 terms are given as 50, 52, 35 and 46, what is the fifth term? So let us have look over the solution. So the sum of 5 terms will be equal to 40 times 5. That is exactly the formula that is equal to sum equal to average into number of observations. So exact formula is being used here. 40 is the average here, okay, and the 5 is number of observations. So the sum of these 5 terms is 200. And now if you see, you are provided with other 4 observations, the precise values of other 4 observations. And since the sum is known to you and all the other 4 observations is known to you, you can take the sum of all those 4 observations and take the difference from the sum of 5 terms. Then you will automatically will have the fifth term. So the fifth term is equal to 200 minus 50 minus 52 minus 35 minus 46, which is equal to 17. So the fifth term is 17. So the correct option here will be option number C, 17. Let us move ahead to problem number 2. What is the average of 512, 620, 428 and 580? So this is a very direct question in which 4 observations are provided to you and you have to just find the average. That means the formula that will be used here is total upon number of observations. So the total is going to be 512 plus 620 plus 428 plus 580, which is equal to 2140. So the average is going to be 2140 upon 4, so which is equal to 535. So the required average is 535, which is option number A. Let us move ahead with problem number 3. The average of 6 consecutive odd numbers is 26. So we have 6 consecutive odd numbers and their average is given to be 26. So we are interested in finding the difference between the largest and the smallest of these numbers. So let us see the solution. So let us suppose the first odd number of the list be n. Okay. So that means the other odd numbers will be n, n plus 2, n plus 4 and so on till the 6th term. So apparently this is an arithmetic progression where n is the first term and 2 is the common difference. So the 6th term of the series is going to be n plus 6 minus 1 into 2, that is n plus 10. So now the difference between the largest and the smallest of these values is n plus 10 minus n, that is equal to 10. So therefore the difference between the largest and the smallest of these numbers is 10, which is option number C. Let us move ahead with the problem number 4. The average salary of 12 employees in a company was recorded to be 20,000. If the salary of the manager is also included, then the average salary increased by 2,000. Find the salary of manager. So in this question, the average salary of 12 employees is provided, and it is also given that when the salary of manager, which is the 13th employee now, his salary is also included, then the average salary increases by 2,000. That means the new average salary will be 22,000. So find the salary of manager. So we have to find the salary of manager. Let us have a look over the solution. So the total salary of 12 employees is 20,000 into 12. So this is the total amount, the sum of salaries of all the employees, all the 12 employees. So it is 2,40,000. So the total salary of 12 employees and a manager is going to be 22,000 into 13. Okay, so that is exactly provided in the question because it said the average salary increased by 2,000. So it will be 22,000. So it will be 22,000 into 13 because manager is also included now. So the new sum of salary of all the employees plus the manager is 2,86,000. So now the sum of salaries of 12 employees is known. Sum of salaries of manager plus 12 employees is known. And if I subtract this salary of 12 employees from the salary of 12 employees plus manager, definitely I will be left with salary of manager. So the salary of manager is going to be 2,86,000 minus of 2,40,000, which is equal to 46,000. So the correct option here is option number B, 46,000. Now, problem number 5. The average of a set of 20 numbers is P. If one of the numbers from the set is replaced with 58, then the average becomes P minus 2. What is the value of number that is replaced? So let us suppose the number which is replaced be x. So according to question, 20p plus 58 minus x is equal to 20p minus 2. So that is the sum, okay, of p minus 2 values, p minus 2 times 20. So that is already given because when a value was replaced, the average becomes p minus 2. This is given in the question. So, and on the left hand side, 20p is the sum of all the p values, okay, and 58 minus x is the change. So it is 20p plus 58 minus x equal to 20p minus 40. So we will get x equal to 98, and that is exactly what we wanted to find in the initial stage. So the correct answer here will be option number A, 98. Let us move ahead with the problem number 6. The average weight of A, B, and C is 52 kg. So there are three people, A, B, C, whose average weight is 52 kg. And if the average weight of B and C is 44 kg, and that of C and A is 46 kg, what will be the weight of C? So the average weight of ABC is given, and BC is given, and CA is also given. So we want to find what is the weight of C. So to do that, we are going to find the combined weight of ABC. So that will be given by the average times the number of observations. So here, average of three people we are taking, average of three people ABC. So the total weight is going to be 52 times 3, that is 156 kg. So the total weight of BC is equal to 44 times 2, that is 86 kg, and the total weight of AC is equal to 46 into 2, that is 92 kg. Name them as equation 1, equation 2, and equation 3. And when you take 1 minus 2, equation 1 minus equation 2, you get A equal to 68 kgs. And if you substitute the value of A in equation number 3, you will get C plus 68 equal to 92, that is C equal to 24 kgs. So the correct weight of C is 24 kg, that is option number A. Let us move to problem number 7. Find the average of all the prime numbers between 1 to 50. Give your answer correct to one decimal place. So in this question, first of all, you need to identify what are all the prime numbers between 1 to 50. So the prime numbers from 1 to 50 is 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, and 47. So this is the sum of all, this is the prime number. These are the prime numbers between 1 to 50. And if I want to find the average of all these prime numbers, then I have to take the sum and divide it by number of prime numbers. So here 15 prime numbers lie between 1 to 50, and we need to find the sum as well. So the sum of these prime numbers is going to be 328. So there are 15 prime numbers from 1 to 50. So now the average of all prime numbers between 1 to 50 is 328 divided by 15, which is equal to 21.867. Now the question says round off to one decimal place. So when we round off, we will have 21.9. So the average of all the prime numbers between 1 to 50 is 21.9. The correct option here will be option number D. What is the average of first 60 natural numbers? So this is a very simple and direct formula based question which we have studied in the theory lectures, in which I told you that the average of first n natural number is given by n plus 1 upon 2. And since in this question n is already given to you, which is equal to 60, so it will be 60 plus 1 upon 2, and it is 30.5. So the correct option here will be option number C, 30.5. The average of runs scored by 8 players in an inning is 55. If the runs scored by 7 of these players in that innings are 25, 35, 45, 60, 65, and 80, then how many runs are scored by 8th player in that inning? So let us have a look over the solution. So the total runs scored by 8 players is average into number of players, which is 8 into 55. Now the 8th player scored 8 into 55 minus the total runs scored by other 7 players. So if I take the difference, if I subtract the score of 7 players from 8 players, then definitely I will have the runs scored by 8th player. So 88 into 55 minus the sum equal to 70. So the 8th player scored 70 runs, which is option number D. Moving ahead with problem number 10. The average age of 24 students in a class is 15 years. When the teacher's age is included, the average increases by 1. What is the teacher's age? Age of teacher equal to sum of age of 24 students and teacher minus sum of age of 24 students. This method is this approach is very much similar to what we did in the previous solution. Okay, so the sum of age of 24 students is 25 times 16 minus 24 into 15 equal to 400 minus 360, which is equal to 40 years. So the age of teacher is going to be 40 years. Therefore, the correct answer here is option number D, 40. Now, problem number 11. The average weight of 6 girls is increased by 2.5 kg when one of the girl whose weight is 38 kg is replaced by a new girl. And find the weight of the new girl. So the weight of girl replaced is 38 kg. So the total change in weight due to new girl is 2.5 kg per person for 6 people. So the total change in weight due to new girl is 2.5 times 6, which is 15 kg. So the weight of new girl is 38 plus 15, that is equal to 53 kg. Therefore, the weight of the new girl is 53 kgs, which is option number C. Now, the problem 12. The average of U, V, and W is 48, and that of V and W is 48. So, what is the value of U? The total average of U, V, and W is equal to 48 times 3, which is equal to 144. The total average of V and W is 48 times 2, which is equal to 96. So the value of 144 minus 96 is equal to 48. So the value of U is equal to option number D, 48. So now let us see question number 13. The current average age of the family of 5 members is 24. So there is a family in which there are 5 members and their average age is 24. If the present age of the youngest member in the family member is 8, then what was the average age of the family member just before the birth of this youngest member? So there is the youngest member in the family whose age is 8 years, and before the eighth member was born, what was the average age? That is what we want to find out. So the sum of ages of all members presently is equal to 24 times 5, which is equal to 120. So 8 years ago, the sum of ages of 4 members is equal to 120 minus 8 times 5 equal to 80. Now the average age of family members just before the birth of this youngest member is equal to 80 upon 4, which is 20 years. So the average age of family members just before the birth of this youngest member is 20 years, which is option number B. Now, let us move ahead to problem number 14. The average marks of 5 students is 85. If the marks of new students are also considered, then the average marks become 84. What is the marks obtained by new student? Total marks of 5 student is 85 times 5, that is 425. Now the marks of new student is equal to 84 into 5 plus 1 minus 425 equal to 79. Therefore the marks obtained by the new students is 79, which is option number A. Now problem number 15. The difference between the average of P and Q and the average of Q and R is 25. So what will be the difference between P and R? So according to the concept, P plus Q upon 2 minus Q plus P R upon 2 is equal to 25. So now since the denominators are same, I can write it as P plus Q minus R upon 2 equal to 25, which is equal to P minus R equal to 50. Therefore, the difference between P and R is 50. So correct option here will be 50. Now, problem number 16. The average of 47 consecutive natural numbers is 99. So the average of 47 consecutive natural numbers is given to us. And what is the largest number among these numbers? So since the average is 99 and we have 47 consecutive natural numbers, that means 47 is an odd number. So 99 is the middle term, and it is the one value, and there are total 47 values. So 23 will be on the right and 23 will be on the left. And we are interested in the largest value. So 23 values from the right is option number A, 122. What will be the approximate average of all the prime numbers less than 15? Now, the average of all the prime numbers less than 15 is equals to sum of 2, 3, 5, 7, 11, 13 and divided by 6. I will have 6.83. So the correct option here is 6.83. Let us move to question number 18. The average of 5 consecutive odd numbers is 33. What is the product of smallest and the largest of these 5 numbers? So again, using the same concept, we have 5 consecutive odd numbers. So and their average is 33. So that 33 is going to stay at the middle, and rest we have five numbers. So there will be two numbers on the right and two numbers on the left. Okay, so 2 times 2, because here we are considering odd numbers, so we have to take 4 steps. That means two skipping two odd numbers after 33. The next number, the very first odd number is what we have to write here. So that is gap of 4. So it will be 37 and the smallest is 29. So the product is equal to 29 into 37 equal to 1073. So moving to problem number 19. What is the average of 6 multiples of 10? So the first 6 multiples of 10 are 10, 20, 30, 40, 50, 60. So the total first 6 multiples of 10 is equal to 10 plus 30 plus 40 plus 50 plus 60 equal to 210. So the average is equal to 210 upon 6, which is 35. So the correct answer here will be option number B, that is 35. Now, the average of 4 consecutive odd numbers is 8. If the next odd number is also considered, then what will be the new average of these 5 numbers? So let's suppose the 4 consecutive odd numbers are y plus 2, y plus 4, and y plus 6. So according to question, y plus 2, y plus 4, y plus 6 is equal to 8 times 4. So it will be 4y equal to 20, y equal to 5. So now the last number is 11. The next number is 13. The total 5 numbers is equal to 32 plus 13 equal to 45. So the average equal to 45 upon 5 equal to 9. The average of these 5 numbers is 9. So the correct option here will be option number 9. So thank you very much. This would be all for this lecture, and I'll see you in the next lecture with few more previous year questions. Thank you.